Hello, Math 111 Pre-Algebra Skills for College Success class. This is Michelle Long, your instructor, and I have developed a podcast for you to assist you with your homework assignment. And your homework assignment is for this week, Skill Builder 3.1 through 3.6. And it refers to Chapter 8, and Chapter 8 in your book is decimals and percents. So by now you should have reviewed Chapter 8, and in this particular podcast we're going to be reviewing Section 8.1, which is Understanding Decimal Fractions, Section 8.2, Adding and Subtracting Decimal Expressions. Chapter your book is on page 428, and it will be reviewing the skill builders that you were assigned for homework, 3.1, which is using decimal notation, 3.2, comparing, ordering, and rounding decimals, and 3.3, which is adding and subtracting decimals. So I would advise you to get your homework assignment out and have it in front of you, because I'm going to walk you through these three skill builder assignments that you're going to have to complete. Okay, a decimal fraction. What is a decimal fraction? Basically what a decimal fraction is a fraction where you have a denominator that is a power of 10. And what a power of 10 is a number that ends with a 0. And it has zeros in it. So it starts with a 1 and it ends with zeros. It doesn't have any other number in it other than starting with a 1 and then zeros. So that basically makes it a power of 10. When your power of 10 is in your denominator, in your fraction, it makes it really easy for conversion. But before we talk about conversion, what we're going to do is I'm going to discuss the actual decimal. So your decimal has a point in there, and it's usually between two numbers, or it can be before a number. And I also uploaded a decimal place value chart, which also depicts the decimal number as well. So that handout has been uploaded in this week's Moodle. So anything that is to the left of a decimal is considered the whole number part. Anything to the right of a decimal is considered the decimal number. The point is indicated by the decimal point, and you can start using and now, where before we couldn't say and. Like for instance, we couldn't say 257. We weren't allowed to say that. But now that we have a decimal point, we can replace that decimal point with the word and. So anything to the right of the decimal point is the decimal part of the number, and anything to the left of the decimal is the whole number part, which indicates the positive on a number line, and the decimal part indicates the negative on a number line. Writing word names for decimals. Okay, so there is actually a guide for this, and you do write decimal numbers. You basically write decimal numbers just as you were to look at them and read them in your mind and say them, is basically how you write a decimal number. However, there's just one little trick that you do at the end of your decimal number, and that's you have to put in the value of the last number in the decimal number. So as an example, for A, we have 0.073. Well, the 0, it starts out with a 0. Any zeros to the left of the decimal point really have no value, none whatsoever. It does not change the value of the decimal number at all. Basically, some formal, informal ways, whichever you want to call it, sometimes people do put a 0 there before the decimal point. It does not have to be there, but basically what it does is it indicates to the reader that there is a decimal oncoming. So this way, when you see the decimal point, you don't forget about the decimal point. The 0 is kind of letting you know that there's a decimal point oncoming. So the number that we're focusing on is 0.073. This is our decimal number. This is how the number that we're going to actually write. So since there is no whole number part of this decimal number, we do not have to put the word and in there. We do not have to include any whole number part. So we're only writing out the decimal number for the decimal word for the decimal number, which is 0.073. We look at the number at the end of the decimal number, and we see that it's the number 3. We have to figure out what value that is. Now, since we've memorized our place value chart, we know that the first number after the 0 indicates tenths, the second number is hundredths, and the third number is thousandths. I would definitely recommend to at least memorize those 3 number values after the decimal point. And also notice that in each one of these examples, the decimal number, when written out, ends with THS, and it doesn't matter if it's hundredths, tenths, thousandths, it's always going to end with a THS. So if you're asked on a test, is this number a decimal number or not, and it ends with a THS, then you know yes for sure that it is most definitely a decimal number. So we're going to write out 73 as a decimal number, 73, and then we have to just end it with the value of the last number 3, which is thousandths. So we actually say this as 73 thousandths. C, there's a whole number portion of it, and this is where and comes into play. 4 is just going to be written as the whole number 4. The decimal itself is going to be replaced with the word and. Then we're going to look at 68, and that is our decimal number, and we're just going to write 68 out and look at the value of the last number in the decimal number, which is 8, and that happens to be hundredths. So we're going to write it as 68 hundredths, making sure that you have that THS at the end. So B is written as 4 and 68 hundredths. So just remember that little hint at the bottom there where I gave the example on the left-hand side. Just please memorize that when you're writing out your decimal numbers. Denominators having the power of 10, and we're writing the fractions as a decimal. This is probably the easiest way that you can convert, because basically the shortcut is if your fraction has a denominator and has a power of 10, each one of these examples have a power of 10 in the denominator. All you have to do is look at the numerator, or actually you have to look at the denominator, and you have to look to see how many zeros are in your power of 10. That's the first thing that you do. The first thing you do is focus on the denominator. How many zeros are in 9 over 10? 1. Therefore, that is how many digits we're going to have in our decimal number. So one zero in the power of 10, 1 digit in our decimal number. So B, we're looking at the denominator as the first thing we do. When there's a power of 10 in the denominator, we have to convert it to a decimal. We have to count the number of zeros. There are 3 zeros in 1,000. Therefore, there are going to be 3 digits in our decimal number. So our decimal number converted 136 over 1,000 is 0.136. And that's stated as 136 thousandths because there are 3 numbers in the digits, so it's 1,000. And it also, another hint is that the denominator is thousand, so we know it's thousandths. And D is an example where you have a fraction, but it has a whole number component attached to it, therefore it makes it a mixed number. So it's actually 34 and 86 thousandths, 86 over 1,000. That 0 was not there originally, so I just want to point that out. So here we have 3 zeros in our denominator. We're going to have 3 digits in our decimal number. Now notice that our decimal number is going to have 3 digits. The 34 is the whole number portion of your fraction. And remember what we said, anything to the left of the decimal point indicates whole number. So we're just going to put that 34 there before the decimal point, and then our decimal number is going to have 3 digits, and then we're just going to bring over the number in the denominator as the digits in our decimal number. So here we have 86. We need 3 place values in our decimal number, therefore we have to add a 0 before the 86. that makes it 86 thousandths. If we didn't put a 0 there before, it would only be 86 hundredths and would not match the denominator. So we want to make sure and just know that anytime that we put a 0 before any numeric numbers in our decimal numbers is going to change the value. If we put zeros at the end of our decimal number, it doesn't change the value at all. Here we're going to do the opposite of what we just did. We're going to change the decimal number to a fraction. So basically what we have to do here is we have to look at the decimal number and we have to count how many numbers are in our decimal number. We have 4. Therefore, there are going to be 4 zeros in our denominator. So 4 zeros and a power of 10 will make it 10,000. And then what we do is we just bring the decimal number over as our denominator. As our numerator, as our numerator. And that makes the decimal convert to a fraction. That's the easiest way that you can do a decimal number conversion to fractions. Pretty simple. And then, of course, you would have to simplify it, but since 7131 is a prime and it does not go into 10,000, it is in its simplest form or lowest term. So we cannot break that fraction down any further. Okay, so B is a little bit more complex because it has a whole number portion to it. So the whole number portion to it is 42. So the decimal that we want to convert to a fraction is 42.019 or 42 and 19 thousandths. 42 is just going to come over as the whole number portion of our mixed number, and we're going to look to see how many digits are in our decimal number. We have 3 digits. 019, that makes it 3 digits. Therefore, we're going to have 3 zeros in our denominator. 3 zeros and a power of 10 makes it 1,000. So our 1,000 is going to be our denominator. We're just going to bring the number 19 over as our numerator. As our numerator. So 42 and 19 thousandths. We're going to take two numbers and we are going to order them from smaller to larger, and we're going to indicate that by the greater than or less than symbol. They could be equal to also, but in this case it's greater than or less than. Please remember that the Pac-Man theory of greater than or less than, that the nose points to the smaller number and the mouth points to the larger number. So here we have 0.894 and we're supposed to indicate whether or not that is larger or smaller than 0.89. Well, since there are 3 digits in 0.894, it makes it easier if we just make the 0.89 3 digits so we can make a better comparison. And usually horizontally is a little bit more difficult in determining numbers and their less than or greater than values. So what I suggest down at the bottom is putting it actually in a vertical format. So it's easier in the eye, and you can look at it and say, oh yeah, well, just by looking at that I can tell which number is greater. Of course, 894. So 894 is greater, so you would point the greater than symbol to the mouth to the 894, and the nose would point to the 89 because that's smaller. Please know the definition of how to round decimals. It's very similar to the definition of how to round whole numbers. The only difference is that you drop off the remaining numbers after the round off number. So I'll get to that. So here we have the place values. Please memorize these place values. The first number after the decimal is always a tenth position. It's never the ones, because we skip over the ones, we go right to the tenths. Then the second number after the decimal number is hundredths. Third, thousandths. And then we start with the new pattern. So then 0 then would become 10 thousandths, 100 thousandths, millions, 10 millions, 100 millions, and so on and so forth. So know that pattern and know your place values, especially the 3 place values after the decimal. So in order to round a number to the nearest tenth, or decimal number I should say, to the nearest tenth, you want to, first of all, you have to know what the round off digit is, and that is in your tenths position. So of course these positions are not going to be on a test, you would have to know them. Tenths is 0. We have to look at the next place value to the right of that 0, which is 4. And there are 2 things that we have to look to determine what to do with the number 4. And that is, if the 4 is 4 or less, we're going to just remove all the digits to the right of that 4. But if it's 5 or greater, we actually add 1 to that 4. To the tenths, to the tenths, and we keep it at 51.1. So let's look at the tenths position at 0. The number to the right of that is 4. Is that 4 or less? Yes. Then we keep the tenths position at 0. If it was 51.058053, that number is actually 5 or greater, so then we would increase 0 to 1. But here we don't have to do that because the hundredths position is 4, and that's 4 or less. We just keep the round off digit, which is the tenth position, and the number 0 to itself. We don't do anything with it. We just keep it at 0. And we drop off the remaining digits. So notice that we did not put 48053 after the 0 because with decimals and rounding decimals, we're just dropping them off. They don't exist anymore. Here's another example of rounding decimals. So what you can do is make a habit of either circling the round off digit or pointing an arrow to it so it doesn't interfere with any of your movement or rounding. You can just point an arrow to it from afar. So the number that we're asked to round to the nearest hundred is 369.2649. Okay, so obviously the first thing you want to do is find out what our round off digit is and find out what we're rounding. We're rounding to the nearest hundredth. So since we've memorized our hundredth position, we can actually point an arrow to the 6 because that's the hundredth position. So the next thing we want to do is we want to look at the number to the right of that because that is our critical digit. It's called a critical digit. And we have to look to see is that 4 or less or is it 5 or greater? Well, it's 4 or less, so we're going to keep it at 6. And remember, with rounding decimals, we just drop off the remaining digits, so we dropped off 49. So rounding 369.2649 to the nearest hundredth position is 369.26. Here we're going to ordering fractions. You could actually convert these fractions to decimals, and it makes a heck of a lot easier to figure out numbers ranging from smaller to larger when you're looking at decimals. It's a lot easier than looking at fractions. You can do it that way. If you don't feel comfortable converting fractions to decimal, there's another way you can do it. And the other way is you want to find a common denominator of each one of these fractions and then look at the equivalence of each one of those fractions and determine its greatness by looking at the numerators. So I'm going to give you that example. So from ordering these from least to greatest using the least common denominator method, the first step is you want to find the least common multiple for each one of these fractions denominators. So in other words, we could find the least common denominator of each one of these fractions. Now you can use the prime factorization method that I taught you last week. So if you're not familiar with that, please go back and look at my podcast. I did a couple of podcasts reviewing how to do that. We're going to list all of the denominators. So the denominators are 4, 3, 7, and 6. We're going to find the primes for each. Okay. So the primes for 4 are 2 times 2. The prime for 3 is just 3 because it's a prime, and the prime for 7 is just 7 because it's a prime. 6 is a composite, so we can actually take two numbers and multiply together 3 times 2, and that is primed. So by looking at these numbers, we're going to find the least common multiple. And by doing that, we're just going to include the first numbers 2 times 2. Okay, and then we're going to look at the next denominator, which is 3. Is there a 3 in our list? No, we're going to add it. Look at the next denominator, 7. Is there a 7 in our list? No, we're going to add it. Okay, so then 6. Is there a 2 in our list? Yes. Is there a 3 in our list? Yes. Good. So we have our least common multiple. And in order to find the least common multiple, we do have to multiply these numbers. So 2 times 2 times 3 times 7 is 84. This is the number that we're going to use as our common denominator. We're going to go to step 2 now. Find an equivalent fraction where each fraction that's given to us originally, which is up top, I did include those original fractions up top, where the denominator is 84. So if you just look at the first column that I included, 3 over 4, and that equals whatever we have to find whatever over 84. So we have to take 3/4 and we have to create a fraction where 84 is the denominator. And that fraction is equivalent to 3/4, because notice there's an equal sign there. All right, so we have to find that numerator. So what we can do is we can either do the missing proportion thing that we talked about, or we can just kind of do it like, how many times does 4 go into 84? Well, if 4 goes into 84 21 times. So we can take 21 and times that by 3. That gives us 63. 3, the next example, goes into 84 28 times. 28 times 5 is 140. The next example, how many times does 7 go into 84? Well, it goes in 12 times. 12 times 6 is 72. The next example, how many times does 6 go into 84? It goes in 14 times. 14 times 1 is 14. So the fractions that we're going to be reviewing and comparing are 63 over 84, 140 over 84, 72 over 84, and 14 over 84. Now that they're all common denominators, we can easily make the distinction as to which one is the least. The one that's the least is the one that has the least numerator, and that's 14. The second least is 63, the third is 72, and then the next is 140. So step is determining which fraction is smallest by the numerator of the fraction with the same denominator, 84. Therefore, the smallest fraction is 14 over 84, and then 63 over 84, and then 72 over 84, and then 140 over 84. 140 over 84 being the greatest of them all. Adding decimals, pretty simple. You just, if you know how to add numbers, that's pretty much the major task in adding decimals. There's just a few things to remember, and that is when you add decimals, you want to make sure that your decimals are aligned. So make sure, like for instance A, we are aligning our decimals. 9.8, 3.6, and 5.4 are the decimals that we're adding. Notice that the decimals are right on top of each other. Makes it easy when you get to your answer, just put the decimal where it's aligned and then do your addition. Same thing with B. We want to make sure that our decimals are aligned, because when we do our answer, we're going to bring down that decimal in the same position where we've aligned it in our mathematics. Sometimes you may get, instead of you being asked in the vertical way, it will ask you horizontally. And when it asks you horizontally, it could be a little complex, because when you align your decimals, they're going to be in all different places. So 8.9 plus 37.056 plus 0.0023 plus 945. Okay, so 8.9, we'll put that first. And then we'll put 37.056, easily enough. You can just align it with the 8.9 decimal. 0.0023, you can align that with the last two decimal numbers. And then with 945, it's always assumed that whole numbers, the decimal point is at the end. It's never actually formally written, but it's always assumed that. Therefore, if the decimal point is at the end of the number, we're going to align that decimal with the last three decimal numbers, and then do our addition. Where the zeros are in pink, you don't necessarily have to put them there, but sometimes if you want to make your addition easier and less complex, you can put the zeros there just to make it so each decimal number has the same amount of values. So it's actually like saying, what is 9,000 plus 56 plus 23 plus 0. So it's kind of like that. It's kind of like each one of the decimal numbers now have 4 digits, which makes it easier when you do the addition. It doesn't change the value, because remember, anytime a 0 is added at the end of a decimal number, it doesn't change the value, and that's fine. Then you just go ahead and you do your addition, and it just makes it easier for your alignment, easier on the eye. And I would also suggest that maybe you would spread out your numbers a little bit more, so your columns are better aligned as well. I mean, we obviously can't do it here because it's typed, but if you're doing it manually, if you're writing it down on a piece of paper on a test, give yourself enough room between each columns when you're doing your addition. Same thing, you want to make sure your decimals are aligned, and you want to practice your borrowing. So if you don't if you are still struggling a little bit with the borrowing, just maybe review B, do it on a piece of paper like 3 or 4 times, and this way the more practice that you get, the better. Because sometimes on tests, whether it's standardized or not, they may ask you to subtract without giving you the option of using a calculator. So just keep that in mind also. But with subtraction, you're just aligning your decimals, and then down at the end when you get to your answer, you make sure your decimals are still aligned. Please remember when you do write your answer that you want to put the decimal in the correct area, because a lot of times when you're doing a lot of work, it can get confusing as to where the decimal place is. So just bring down the decimal first before you start doing your computation. Questions? You should have now more assistance when you're working with your Skill Builder 3.1, 3.2, and 3.3. And again, if you need any further assistance, please don't hesitate to email me, mlong@pit.edu, and feel free to meet with you or Skype.